Hi guys, Daniel here, and today we're going to do an AIME problem. So this AIME problem is the 2015 AIME number 2, problem number 5. So without further ado, let's begin by reading the problem. We have that two squares are selected at random without replacement from an n by n grid of unit squares. When we need to find the least positive integer n, such that the probability that the two selected squares are horizontally or vertically adjacent is less than 1 over 2015. In other words, we have to find the probability of choosing two adjacent squares in terms of n, and setting this to be less than 1 over 2015. So we start with a grid like this, drawing the columns and the rows, and this is an n by n grid. Sorry, bad grid. But anyways, we have to choose two squares such that if they are horizontally adjacent like this, or if they're vertically adjacent like this, then that's a good case. And otherwise, it's a bad case. And we want to find the probability of this being less than 1 over 2015. So one idea is to start with choosing one square, for example right here, and then find the probability that the other square is adjacent to this square, horizontally or vertically. However, this gives some pretty nasty casework, because if you choose the edge square like here, you can choose these three squares, while if you choose, for example, a corner square here, you can only choose these two squares. And finally, if you choose a center square right here, then you can choose all four squares that are adjacent to it. So this involves a lot of casework based on whether the first square is an edge, a corner, or a center square. And it's doable. It's not that bad to do, but it's quite a bit more algebra than I want to do because I'm lazy. So I want to find an easier solution to this. So how might we find this? Well, instead of doing constructive counting, let's choose both squares at the same time. So the total number of ways to choose both squares at the same time is, well, we have n squared squares, and we don't choose 2, so the total number is n squared over 2. Total number of ways to choose. And to find the probability of getting two selected squares that are horizontally or vertically adjacent, we just count the number of pairs of squares that are horizontally or vertically adjacent. Fortunately, this is a much easier task than all the casework that we did before, since when two squares are horizontally or vertically adjacent, they share an edge. For example, this edge, or this edge, or this edge, or this edge. So basically, we just want to count the number of edges in this n by n square lattice. And this is not that hard to do. For example, for the number of horizontal edges, well, each row has n edges here, and there are n minus 1 rows, which gives a total of n times n minus 1 at horizontal edges. And since the same is for vertical, we have a total of 2n times n minus 1 ways to choose adjacent squares. And now we're done with our probability, since we now have the number of ways to choose adjacent squares and the number of ways to choose two squares in general. We just divide one by the other and get the probability of choosing the two selected squares chosen are horizontally or vertically adjacent. And this is simply 2n times n minus 1 over, expanding the bottom side into the algebraic form, we get n squared times n squared minus 1 over 2, which simplifies into 4 over, well, we have an n cancel out with one of these n's, n minus 1 cancel with the n minus 1 here, leaving n plus 1. So we're left with 4 over n times n plus 1. And we know that this is less than 1 over 2015. And now it's just a simple calculation of the largest n possible, or the smallest n possible, and this n is just equal to n equals 90, and this is the smallest, and so we are done.
Hey guys, Zong here, back to another math video. Today we're going to be doing an AIME problem.